Hi everyone, I hope you are doing well. So in this video, we are going to discuss Leetcode problem of the day, and today's problem is arithmetic slices to dash subsequence. Right, and it is a hard level problem. So I was actually busy with some contests since the morning. That is why I was not able to upload the videos. So anyways, now let us discuss this particular question. The question simply says that we have been given an array nums and we have to find the number of all arithmetic subsequence of nums, and the subsequences should have at least 3 elements. This is our condition, right? So how do we actually solve this particular problem? I believe there would be actually multiple ways of solving this problem, but we are going to solve this problem with DP, and again with DP also there are multiple ways to define the states. So if you have any other ideas, you can definitely comment it down. I'm going to discuss my idea of how I formed the DP states and how did I solve this particular problem. So arithmetic sequence is basically, if I have an element A, B, C and D, the difference between these consecutive elements should be constant. So dx, dx and dx, right? So I said I am going to solve this problem with DP. Let us define a DP states then. So I am going to form a double dimensional DP of ij, and my I is going to denote the number of the current position, let's say, and j is going to define the current difference, right? Now my dp of ij together is going to define the number of subsequences starting from current position with current position I with the common difference j, right? So this is what my dp of ij will define. Now how do I actually solve this particular problem? Let's say we have an array. So I'm just going to draw an array. Let's say we have this particular array with certain items. We have some values, let's say A, B, C, D, E, F, G. So first of all, I'm going to have a nested for loop. Let's say I have a for loop I 0 to n, and then I have a for loop j till n, right? Now I'm going to get the value of difference dx is equals to array of j minus array of I. So till now what do I have? For each elements I can form the pairs. So for A I can form AB, then AC, then AD and then AE and so on, right? So for each of these pairs I will get some common difference dx, right? So now what I can try to do is, once I have formed these pairs, once I have figured out the common difference dx, I can give the task to, let's say, E. For this current common difference between A and E, I can give the task to position E, find me the number of subsequences, or find me the number of, find the total size of the subsequence that start from E and have a common difference dx, right? So let's say I have 1 and then I have 3 and then I have 5 and 6, 7, right? So I make this particular contact with 3, right? So the common difference between them is 2, right? So I ask 3, how long can you continue this particular sequence with a common difference of 2, right? Now let us see what will 3 reply to me. So 3 will say that, okay, I have this one element in front of me and I have this another element in front of me and I am the element itself, right? So let's say it gives me 3 is the answer, right? So it is going to tell me this particular position that, okay, with this common difference 2, I can have 3 elements after this particular one. So starting from 1, how many answers can I form? I can form 1, 3, then I can form 1, 3, 5 and I can form 1, 3, 5 and 7, right? So these are all the subsequences. Now since we want only subsequences of length greater than 2, I can subtract this particular subsequence, or I can subtract 1 from the total answer this particular value gives me, right? This is my whole idea. I'm going to iterate this particular part again. So let's say, right, I am at this particular position. With this element, I am able to figure out a difference value, right? Now my question is, what is the maximum length of the sequence I can form starting from this particular position such that the common difference is dx, right? So I give this task to 3, right? So 3 is going to give this similar task to 5 and 5 is going to give this similar task to 7. So 7 will actually return 1, 5 will return 2, 3 will return 3 to me, right? So once I get this 3 here, those 3 subsequences will be actually 1, 3, 1, 3, 5 and 1, 3, 5 and 7, right? Out of which I need only the subsequences which have length greater than 1, greater than 2 actually. So I'm just going to remove this particular subsequence, right? Now my question is, I know I understood this part. How will this actually work in code, right? So let me just write some pseudocode to help you understand better. So let's say I have my helper function here. I have received my position p and I have received my difference dx, right? So now what I'll do is, first of all, I'll have my dp states. If dp of p dx is not equals to -1, that means if dp of p dx has been calculated, I'm just going to return dp of p dx. dp of p dx, right? Now I take the value dx, so I know what is the next value that I need. That will be nums of p plus dx. So this is the next value that I need. What I can try to do is, I can figure out all the positions. Let's say all the positions I have is something in my positions vector. Positions vector. So let's say this is going to contain all positions after p which have the value need, right? So this position vector, we are going to have a look at how we are going to compute this, but let us assume that this position vector has all the positions after p which have this particular value need, right? So now what I'll do is, I'll add dp of p dx. So first of all, I'll initialize my dp of p dx with 1, because this can be the position or the ending position, right? For example, the 7 in this particular case, if we carefully look at 7, so if you carefully look at this particular 7, this 7 should be returning 1, right? Because if it does not return 1, I will never be able to get the size of this particular sequence which have this common difference, right? So now let's say dp of p dx, I will initialize with 1 and I will go through all the positions, right? So I am going through all the positions. This positions vector I have defined what it does. How are we going to calculate it? We are going to have a look at it in a while. But let's say these are all the positions. So dp of p dx will be basically equals to helper of this position I comma dx, right? So what I am doing, I am trying to add all of the answers that I can get from these positions. So I will be the position which is greater than the current position p and still has the same common difference, right? So once I get all of these values, once I add all of these values, I'm just going to return dp of p dx, right? So this will be my helper function. So how am I going to call this original helper function? I'm going to have my simple two for loops here which are going to call, let me just write it also. So let's say this is my first for loop, this is my second for loop, and for each of these for loops I need to find the starting position and the dx, right? So let's say this is for loop for I, this is for loop for j. I can calculate dx as, let's say, nums of j minus nums of I, right? And I can add my answer is equals to starting from this position j. So I have to call helper of j because I am trying to find from position j, and my dx, I am going to pass my dx, right? So you see what I am doing is, for all the pairs in the original array, I am trying to find their common difference. Then I am giving the task to one of the elements in that particular pair, more importantly the second element, that tell me the size of the maximum sequence that can start from u and have this common difference dx, right? So this position p and with this like the common difference dx, I am going to get the size of the subsequence. So why is the size of the subsequence important? Because let's say this is my element I, this is my element j, and my element like the sequence continues like this, p, q, r and s. So I can form all of the sequences like I, j, p. Then I can form the second subsequence like I, j, p, q. Then I can form the third subsequence as I, j, p, q, r, and the final subsequence as I, j, p, q, r and s. So the size of the sequence that I can form will actually determine the number of subsequence I can form starting from this position with the common difference dx. Once I have covered all of these cases, I will get my final answer, right? So this was all about this particular problem. Now let me just show you the final code. So what I have actually done is, so I've initialized with my size of the array with nums of size, right? I've initialized my dp. So this is going to be a double dimensional dp where the second dimension is actually defined by an unordered map, right? Because there can be different common differences or the value of dx can vary. That is why I have not defined it explicitly. I've used a map here. Now we talked about calculating the positions. So what I'm doing here is I'm creating an unordered map. So what it will essentially do, for all the values, let's say I have the current value nums of I am going to store at what indexes it is present. So my positions is going to store for each of the elements in the array at what positions those elements are present, right? So this is my post map is doing, right? So now I have initialized my answer with this value, although it is not required. Let me just remove it from here and we'll discuss a better alternative which will be easier to understand, right? So let's say I initialize my answer with 0, although the previous code would have also worked, but I'm going to make you understand this in a better way, right? So now we have these two for loops which we're talking about. So this for loop starts from 0 till less than n, and this actually starts from I plus 1 till less than n. Now I give the task to my helper function to start from position j and have this common difference, right, which is nums of j minus nums of I. I've just taken it long to avoid any overflow. So this is the common difference that we have, and I've given my task to my helper function to find the size of the sequence that I can have. Now since this particular sequence will also have one subsequence which is going to be of size 2, I can subtract -1 from here, right? So this is what I do here. Now inside my helper function, if dp of p, since this is a map, I cannot access the dx element directly, so I just check if dp of p has this element dx or not. If it already has, I'm just going to return dp of p dx, otherwise I initialize my dp of p dx with 1 and I set my need value with nums of p plus dx. So nums of p is my current value, dx is the common difference that I need, so need will have this particular value nums of p plus dx, which is because this is going to be the next value that I will need in my sequence. Now I initialize my next value, so this is actually going to store the position of the next correct need that I need. So position, this particular post map already has all the positions of this particular need value, right? So what I'm going to do is I'm going to perform a binary search using lower bound in this need vector. So positions of need, I have a vector of all the positions at which this particular element need is present, right? So once I get all the positions, I'm going to perform a binary search. So let's say here I have this 1 1 1 1 1. So let's say this is position 0, this is from position 5, this is some 7, this is some 10, and this is some let's say 12, right? So what I'm saying is I'm currently at position, let's say 6. I need the value 1, right? So I already have this positions vector 0, 5, 7, 10 and 12. I am currently at position 6, I need the value 1. So I want to find out the next valid position. So that is why I perform the binary search in this particular vector 0, 5, 7, 10 and 12. So the next valid positions will be 7, right? So this is what I'm doing here. I'm trying to find out the index of the next valid position, right? So this is how I can get it using lower bound or this particular positions of need map, right? Now starting from this next position going till all the way up to all the valid positions, I'm going to do dp of pdx plus helper of positions of need I comma dx. So my dx is always going to be the same, the common difference, but my positions of need of I, what is this? So positions of need of I is going to contain the next valid position. This next just had an index to that particular position. I'm just going to traverse starting from next till less than the size of this particular vector, and for all of those valid positions I'm going to add this particular value to my dp of pdx. At the end I can just return dp of pdx and this would be my final solution. So let me just quickly run this first and check whether this works or not. So you see this passes here, and let me just quickly submit this. So you see this passes all the test cases and the solution is absolutely correct. I hope that you guys were able to understand the solution. If you guys did, then do consider dropping a like on this video and don't forget to share thoughts in the comments, because your engagement with this particular video really helps the YouTube algorithm to understand that this video is actually helpful for you and it will be able to reach much more people like you who want to keep solving new problems. So that is it for today. Till the next video drops, keep coding, stay safe, bye bye.